So the topic of the session is statistics. What is statistics? As we know, mathematics has always been differentiated from statistics because statistics is a branch of mathematics which is going to deal with the data, or the primary and the secondary data collection through which we do statistics. Imagine we try to study the population of the country every year, every 5 years. In the census, we do calculate the population for every 5 years, and we make a data of all the different 5 years, say for example for 2014, then 2009, and then 2004, etc., for every 5 years for which the population is recorded. Now this data is very useful in making some statistical predictions. Therefore, the other name for the topic statistics is data, because the first thing which comes into existence for this is data collection. Now every statistical problem deals with the data. How do you collect the data? So for example, I have 40 students in the class, or have 26 students in the class, and I want to record the marks they obtained in mathematics for all those 26 students. Say there are 26 students through which I have the student A1 who got 76 out of 100 in the mathematics subject. Now the student A2 who got, say, 82 marks out of 100 in mathematics, and similarly the student A3 with 64, and A4 with 53, and A5 with 90, and A6 with 27, and say etc. There are different data collections through which the marks are obtained by the student. Now coming with A7, then A8 is a student who got 74, say, out of 100, and A9 with 76, A10 with 65, A11 with 47, A12 with 54, A13 with 36, A14 with 12, and then now coming to the continued data, I take my A14, which is for 36 marks, next continued with 12 marks, and my 15th student who got the marks 24, and A16, which is 39, A17, which is 41, A18, which is 69, A19, which is 73, and A20, which is 94. Next, A21, which is 89, and next A22, which is 64, and A23, which is 46, A24, which is 19, A25, which is 53, and A26, which is 69. Now I would like to convert this entire data of 26 students who got the marks in mathematics for their semester exam. So these 26 students who got different marks out of 100, I would like to convert this into a group data. So let's see how I can group the data by taking the students from student 1 to student number 26 and their respective marks in mathematics. Interestingly, this kind of arranged data is what is the initial step of statistics. Arranging the data is very important in statistics. more than understanding the data. So once the data is arranged, we examine, we study the data, and then we make predictions and using different properties of statistics. So let's see how I can arrange this data. Now say for example, I wanted to use these 26 students in the form of a table, a tabular form of arranging this into a grouped data. So for a group data, I take number, student number here, and marks in mathematics out here in the second column. So the subject of student number comes in the first column, and the marks as obtained by the student comes in the second column. Now coming to that, we have the students ranging from A1 to A26, where initially I would start with the students who got the marks or number of students. I can call this as number of students. Now for number of students, if the marks are ranging from 0 to 33, then I wanted to know how many students got the marks which are ranging from 0 to 33. So as I see here, I count all the marks which are 0 to 33. I see 1, and in this column 2, and then 3, and then 4. Therefore, all the students who got marks between 0 and 33 in mathematics are 4 in number. So number of students who got the marks from 0 to 33 are 4 in number. Similarly, I take the students who got the marks from 34 to 50. Then I count all the marks which are between 34 and 50, including 34 and also 50 if it exists in this. Then I count that clearly there are 6 students, because as I see here, 34 comes here 1 to 50, 2, 3, 4, 5, 6. So totally there are 6 number of students who got the marks between 34 and 50. Next, I want to know the number of students who got the marks between 51 and 75. So clearly I find that there are 10 students, because I have 51 to 75, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So totally I count that there are 10 students who got the marks from 51 to 75. So to continue with, next I would like to see how many students got the marks between 76 and 100, and I count them. So I obviously say that the remaining of the uncircled marks are obviously the marks which range from 76 to 100, as can be clearly seen here. That is 1, 2, 3, 4, 5, 6. So there are 6 in number which range from marks 76 to 100. So this table clearly gives us the picture of the entire data of 26 students taken into account with their marks obtained in mathematics. Say for these 26 students who obtained the marks in mathematics for the maximum mark standing at 100, clearly my group data will give me an analyzed picture that if this is the table given, I assume that in the entire class of 26 students, the number of students who got the marks from 0 and 33, between 0 and 33 are 4 in number, and between 34 and 50 is 6 in number, 51 to 75 is 10 in number, 76 to 100 is 6 in number. Thus, concluding that we can make many conclusions through this obtained data, where I can identify that more number of students got the marks between 51 and 75 is how I predict through the statistical data. So this group data helps me in identifying that there are more students who got the marks between 51 and 75, and there are less students who got the marks between 0 and 33, which shows a good sign, because there are less concerns of the students, because there are only four students who have been with great concern for their improvement in the next examination. So these kind of predictions are done exclusively through the data, or more importantly through the group data, where in case of this example problem, I identify that there are less number of students who got less marks, therefore less concerns for the teacher who is teaching the subject. And there are more students who got good marks, therefore this is not a major concern, but definitely a concern on improvement of each and every individual student, and how we connect the given data into the group data and apply it using statistics. So let's discuss the mean, the first measure of central tendency for a data, especially for two types of data. One is the grouped and ungrouped data. So the three measures of central tendency which exist for the data collection in statistics. One is the mean, the next is median and mode. Mean, median, mode are the measures of central tendency for the given data. Now initially, to study about mean, let's try to differentiate the mean of the group data and the mean of ungrouped data. So there are two types of data as we have already identified. Now let's see how we can understand the mean for ungrouped data, and then how we can understand the mean for the grouped data. Now initially, to start with, my mean, which is generally denoted with mu or x bar, is given by the formula sigma fi xi by sigma fi, where xi, which is x1, x2, x3, so on and so forth till xn, are called observations, or they are called the data. Now observations like the marks obtained in mathematics, as in case of the previous problem, then each of the marks as obtained by each and every individual student in mathematics for 100 marks is nothing but the observation. So marks of each student are identified as observations in the data. In the mathematical or the statistical language, we call them as observations. Now, Fi is frequency of each observation xi. Now this is very important, because when I say the number of students who got 56 marks in the class, if I say there are 5 students who got 56 marks in the class out of 100, then I say the frequency of 56 marks is 5, because 5 students obtained that. So number of students or number of times the observation repeats is called frequency. This is a very important note, because in both the data, frequency is identified as the number of repetitions or number of times the observation occurs. So we identify the frequency through the number of times or the number of marks each student gets for that particular mark. 56 marks, 5 students, so frequency of 56 is 5, is how we understand. Frequency is number of times the observation repeats. Now similarly, when I come with mean of ungrouped data, is how I understand this, where for a group data I have the mean, this, or x bar, as again sigma fi xi by sigma fi. The formula doesn't change, but the only thing which changes is the observation, because here we have the direct observations x1 to xn, but here xi is the mid value of each class. So when we come to the group data, the only thing which differs is that frequency is same, but xi, because it is in the group form, we take the mid value of each class interval. So let's see that in brief when we come to the example problem discussed in brief for the group data. Initially, we will try to understand how ungrouped data can be used to calculate the mean. To start with the first data, that is ungrouped data, finding mean using ungrouped data. Now let's take the similar example as we have taken in the previous case, where the number of students in the class and the number of students who got the marks in mathematics subject is what we're going to take as an example problem to understand mean for ungrouped data. So let's take this example problem. So I take the data number of marks in max is one column, and then number of students in class is next column. Is how I differentiate the two columns, the number of marks obtained in max and number of students in the class. So each of that I will take. Now clearly number of students in class is frequency because it is the number of students which decide on each student getting as different marks. Therefore I take the frequency Fi here, and the observations are the marks obtained by each student. Therefore each of the observations comes in the first column as Xi, and each of the frequencies, which is Fi, comes in the second column. So let's take the data. For example, I have the data 10, 20, 36. Now each of the marks of students in mathematics has been given with the data of number of students who got, say, 10 marks in the entire class, which is the frequency. As we told, that frequency is the number of times the observation occurs. Then clearly here, if I say, for example, the frequency is 1, which makes me understand that there is only one student in the class who got 10 marks, is how I understand the real life situation using the frequency value. So if my frequency, say for example here, is 3, then I say that there are 3 students in the class who got 36 marks out of 100 marks. So identifying this, then proceeding similarly, I get, say my frequency is 4, 3, 2, 4, 4, 1, 1, 2, 3, 1. So each of them have been respectively identified with the frequency, where 50 students got this 56, 60, 70, 72, 80, 88, 92 and 95 is how we identify the number of marks connected with the frequency of the class. Now coming to this, let's see how we can calculate the frequency, the mean of the group ungrouped data. Now this is ungrouped data because we are not grouping the marks, but we are straight away taking the marks of each and individual student. So this cannot be a group data, as clearly be seen with the first column, where the marks are directly related with the frequency, but not with the group of students, but the each and individual student of the table. Yes. So coming to this, let's see how I can calculate the total frequency, that is sigma Fi, because my mean is sigma Fi Xi by sigma Fi. Then in this case, I make a new column which I need is Fi into Xi. So I multiply this with this to get Fi into Xi with this. 10 times of 1 is 10, 20 times of 1 is 20, 36 times of 3 is 90, 108, and 40 times of 4 is 160, 50 times of 3 is 150, and 56 times of 2 is 112, and 60 times is 240, and 70 times of 4 is 280, and then 72 times of 1 is 72, and then finally 80 times of 1 is 80, and 88 times of 2 is 178, 176, 92 times of 3, 270, 276, and 95 times of 1 is 95, is how we get the Fi xi of the Fi and xi individually. Now here, with each of Fi xi and Fi into xi, we have to calculate first sigma Fi, which is sum of each of the frequencies of the table. Now when I add them, I get 1 plus 1 plus 3, 5, 5 plus 9, 13, 16, 17, 18, 18 plus 8, 26, 27, 28, 29, 30, 3. And then finally, when I add up, I get this to be 30. The total frequency is 30, is what I get out here. Now next, coming to sigma Fi xi, I had to add each of the values which I obtain on adding as 1779 is what we get for sigma Fi and sigma Fi xi. Now with these two values, we have to find the mean of the ungrouped data, which is the example problem. Therefore, my mean x bar or mu is given by the formula sigma Fi xi by sigma Fi. Now with this formula, I substitute the values of sigma Fi xi by sigma Fi, which approximately on division simplifies to give you 59.3. Therefore, mean of the given problem is 59.3, is how we identify the mean of this ungrouped data. So what is this mean? What is the significance of this value of the entire problem? Now what do I mean that my mean is 59.3 is understood in more general sense of this real life problem is the biggest question when mean is calculated. Mean, in other words, is also called the average. Therefore, this gives me the clear understanding that the average marks of the entire class is 59.3. Though there are one student who got 10 marks and there are the highest being 4 students who got 60, 70 and 40 marks, then my clear picture for the teacher to understand gives me that in the entire class we have the average of 59.3. The average of the entire class is 59.3. So mean helps us in identifying the average of the class. So average marks of the entire class being 59.3 is not a bad average, but a medium average in the entire class is how we understand mean in real life. Mean is average, and for ungrouped data, this is how we do through an example problem. Now let's see how we use the mean for group data for the same problem that what we have discussed in the previous session for ungrouped data. So in this session of group data, I attempt to convert the given ungrouped data in the previous problem into the group data. So how do I convert an ungrouped data into a group data is the biggest question out here. And when to use the group data and also when to use the ungrouped data is also the biggest question of the session. So usually group data is used when the data is very large, because if I have say 200 students in the class for which I want to calculate the individual marks may not be an easy task for the teacher. Therefore, for 200 students with their individual marks in mathematics, we try to group them as 1 to 20, 20 to 40, 40 to 60, etc. till 180 to 200, so that the group reduces the number of marks we're taking for each and every individual student. So grouping the data restricts the whole or the large data. So group data is generally used for larger data. Is very important, used for large data. When the data is very large, like 1,000, 200, 500 in number, then in that case we use grouped data. So for the previous problem, let's try to convert into the group data. So let me form a group of 50. Now forming a group is totally the choice where it is left to the student, because the grouping can be done in a group of 20 or a group of 10 or a group of 20. So I try to group them in the most simpler form as number of marks in max as obtained through class interval. I denote this as class interval because the class interval is what is denoted for the group. Now let me take 15 in number, that is my least marks is 10 and my highest marks is 95, and because the highest marks in mathematics is 100, the paper is for 100 marks. Therefore, I group that using 15 in number. So 10 to 25 is between 10 marks and 25 marks. There are 15 in range. So each of the class interval is ranged in 15, that is 25 to 40, 40 to 55, to 70, 70 to 85, and 85 to 100 is how I get the range of 15 marks in each of the case. Therefore, my class interval, which is number of marks, is ranging between 10 to 25, etc. and etc. Next, let me take the number of students, which is the frequency. Now here, I count in the group data, as in the previous problem, I count all the students who got between 10 and 25. So number of students who got the marks between 10 and 25 are 2 in number, is what I count in the group data, and then I get 2 as the frequency for the group 10 to 25. Next, I count the number of students who got the marks between 25 and 40, and I count them to be 3 students who got the marks ranging from 25 to 40. And also, when I see between 40 and 55, I get 7 in number, then I get 6 and 6 and 6 in number. Now this is said to be the grouped data, where the class interval and the frequency is given out here. So this is how we have number of students and number of marks obtained in groups. So the complete data, which had so many huge data out there, is restricted to the most simplest data, which has only 6 groups. So for large data, the group data helps in calculating the measures of central tendency, mean, median, and mode. So to start with, let's take xi. Now as we have seen that xi here is the mid value of the class interval. My xi is the mid value of the class interval. Now what is the mid value of the class interval? This. If I just come back to this, my class interval with 10 to 25, this is called the lower limit and this is called the upper limit. So 10 is the lower limit of the class interval and 25 is the upper limit of the class interval. Say for example, I take this class interval, then I see that in this class interval ranging between 55 to 70, 55 is the lower limit and 70 is the upper limit, is how we understand. So to find the mid value xi, we have the formula mid value xi is given to be lower limit plus upper limit by 2 for that particular class interval. So lower limit plus upper limit by 2, in this case being 10 plus 25 by 2, that is 35 by 2, which is 17.5. Therefore, the mid value of this class interval is given to be 17.5 is what we get as the mid value for this. Similarly, for the class interval ranging between 25 and 40, my lower limit is 25 and my upper limit is 40. Therefore, 25 plus 40, which is 65 by 2, gives me 2 3s, 2 2s, 2 5s, which is 32.5 is what we get. And similarly, when I take 40 to 55, which is 95 by 2, that is 2 4s are 8, 2 7s 5, which is 47.5. And this being